Nuclear fusion is the process that powers the sun and the stars. It's nature's way of making energy by joining small atoms together. In fusion, two light atoms, like hydrogen, smash together to make a new, bigger atom. When they do this, they release a huge burst of energy. This is the same energy that makes the sun shine so brightly in our sky. So what makes fusion so special? It is one of the most powerful sources of energy in the universe. Even a small amount of fuel can create a massive amount of energy. This is why scientists dream of building fusion reactors here on Earth. If we can copy the sun's power, we could have almost endless energy. Fusion is different from most ways we make energy today. It doesn't burn coal or oil, it doesn't pollute the air, and if we get it right, it could be much safer than what we use now. Fusion is a dream that has inspired scientists for over 70 years. But turning this dream into reality is not easy. It takes strong machines, clever ideas, and teamwork from all around the world. Yet the promise of clean, safe, and almost unlimited energy keeps us trying. Most nuclear power plants today use fission, not fusion. Fission is the process of splitting big atoms, like uranium, into smaller pieces. This also releases energy, but in a very different way. Fission can create dangerous waste that lasts thousands of years. It can also cause accidents like in Chernobyl or Fukushima. Fusion is much safer. It uses lighter atoms like hydrogen, which are not radioactive. The waste from fusion is far less dangerous and goes away much faster. There is no risk of a big meltdown or explosion. In fact, if something goes wrong in a fusion reactor, the reaction just stops. Fusion is also much cleaner. It does not produce greenhouse gases, so it will not add to climate change. The main byproduct is helium, which is safe and already used in balloons. Fusion does not pollute the air or water. Best of all, fusion uses fuel that is easy to find. Some of it can be taken from seawater. This means we would never run out of fuel for fusion. It could give us power for millions of years without harming the planet. Making fusion happen on Earth is very hard. The atoms have to be squeezed together so tightly that they join, just like in the sun. To do this, scientists use special machines. The most famous is called a tokamak. A tokamak is a donut-shaped chamber that uses powerful magnets. These magnets trap a hot, glowing gas called plasma. Plasma is so hot that the atoms inside can fuse together. Another way to make fusion is called inertial confinement. Here, tiny pellets of fuel are hit with powerful lasers. The lasers crush the pellets so quickly and tightly that fusion can start. Magnetic confinement is a different method, where strong magnetic fields hold the plasma in place. All these machines are like star makers. Each tries to copy what the sun does, but in a safe way on Earth. Tokamaks are leading the way, but other designs are being tested too. Each method has its own challenges and promise. To make fusion work, we need to get the fuel incredibly hot. We are talking about temperatures of over 100 million degrees Celsius. That is actually hotter than the core of the sun. No material on Earth can touch or hold something that hot. This is why we use magnetic fields to keep the plasma floating inside the reactor, away from the walls. Keeping the plasma in one place is very tricky. The plasma can be unstable. If it touches the walls, it cools down and the reaction stops. Scientists use powerful computers and smart controls to shape and steady the plasma. Even small mistakes can end the fusion reaction. The inside of a fusion reactor must also handle harsh conditions. Neutrons, tiny particles from the fusion reaction, slam into the walls at high speeds. This can make the materials break down or become weak over time. Finding strong, long-lasting materials is a huge challenge. Despite these challenges, progress is being made every year. New materials, better magnets, and smarter controls are helping us move closer to real fusion power. Around the world, teams of scientists and engineers are building powerful fusion machines. The biggest of all is ITER in southern France. ITER is an international project with experts from over 35 countries. It is the largest tokamak ever built, and it aims to show that fusion can work on a large scale. In the United States, a project called SPARK is being built by MIT and a company called Commonwealth Fusion Systems. SPARK is smaller than ITER, but it uses new types of magnets that could make fusion reactors cheaper and faster to build. Helion is another American company. It is trying a different way to make fusion with pulsed magnetic fields. TE Technologies, also in the US, is testing yet another method with beams of particles. Each project is using new ideas and technology to solve the fusion puzzle. These projects are in a race. They all want to be the first to make more energy from fusion than they use. Whoever wins, the world will benefit from their discoveries. One amazing fact about fusion is its fuel. The main fuel, called deuterium, can be taken from seawater. There is enough deuterium in the oceans to power the world for millions of years. Another fuel, tritium, can be made from lithium, which is also found on Earth. Fusion is a truly global effort. The ITER project has scientists and workers from Europe, Asia, America, and beyond. Each country brings its own ideas, skills, and tools. This teamwork makes fusion a project for all humanity. Fusion reactors do not need much land, they do not use much water. They do not make smoke or waste that can harm the environment. If fusion works, it could change the way we live, travel, and power our cities. Fusion could give us the energy to explore space, clean our air, and protect nature. It could help end our need for oil and coal, but it will take patience, hard work, and hope. Fusion is not easy. It has taken decades of research, and we still have a long way to go. Building a working fusion power plant is one of the hardest things humans have ever tried. It needs new science, new machines, and new ways of thinking. We must solve problems with heat, plasma, and strong materials. But fusion is worth the effort. It could give us safe, clean energy for everyone. It could fight climate change and help us care for our planet. Fusion is a light of hope in a world that needs new answers. No one can promise fusion will be ready tomorrow. It may take years or even decades, but every step forward brings us closer to a brighter, cleaner future. The dream of making a star on Earth is bold but not impossible. If we keep working together, fusion could change the story of human energy forever. It is a promise that inspires us to reach for the stars, and maybe to bring a bit of their magic home.